certificate you want to use, this is actually not the worst way to go. Now, what's funny is this was actually inspired by this old file system called the self-certifying file system. Someone else made this link. It's called SFS HTTP, Securing the Web with Self-Certifying URLs. It was done by some guy, Michael Kaminsky. Michael is my middle name. This was done in '99. There are some scalability issues. What do you do if the certificate is lost? But, like I said, there are some situations where I think it'll actually be really useful to be able to say, please bootstrap your initial connectivity. Here's the URL. And by the way, the URL contains the hash of the identity you're speaking to. And hey, it doesn't have to be a good idea. Sometimes it can just be cool. So, around this point, you might be thinking, now is the time to get rid of the certificate authorities. No. The CAs are, in fact, more critical than ever. There are domains, www.bankofamerica.com, procterandgamble.com, and so on. And there are brands, Procter & Gamble, Yahoo Incorporated. Domains and brands are not the same thing. If you go ahead and you look at what the CAs have done to actually offer value, they have gone ahead and done a program called extended validation where they will say, this isn't just bankofamerica.com, this is the Bank of America Corporation. That's great, because that is something DNS is not going to be able to do. Extended validation has some problems. I can't go into full depth. If you want to know more, look at Mike Zussman and Alexander Sodorov's SSL rebinding attacks from Black Hat last year. And the basic problem is EV only protects you against phishing attacks if the attacker doesn't have a non-EV cert as well. So a bad guy who goes to Lens Certificate Check and gets a certificate for www.bankofamerica.com, he can go ahead and interfere with green bar communication. That's just the nature of the technology. But DKI fixes this. DKI has what we call the exclusionary property. When your DNS domain is registered through Enom, GoDaddy cannot interfere with it. When your X509 certificate comes from VeriSign, GoDaddy can. It's because there's no actual link, no actual forcing function saying when VeriSign's got a cert, GoDaddy can't. But you do have that in DNS. So what you can do under DKI systems is you can say the only canonical certificate for www.bankofamerica.com is the extended validation certificate issued by VeriSign. And any other certificate, I don't care who it's signed by, that cert's not valid. That ends the EV attacks. And while, yes, there are attacks under EV where there are, say, invisible subdomains, things from content distribution networks that load stuff, we can go ahead and we can use the same stuff. It is, in fact, cheaper to deploy a DNS record with those submachines SSL certs than it is to go ahead and get SSL set up on them normally. So exclusion works there too. Before we finish, I do believe that we promised users we would do something about email. Now, I don't know about you guys, but I am sick and tired of trying to find people's PGP keys, and worse, just sort of assuming that what I get back from the key server is valid. Wouldn't it be great if you could securely retrieve them via DNSSEC? Well, we've begun a project. It's called FreeGP, and it actually is porting end-to-end DNSSEC lookups to GPG. You might notice this is a little hideous. I've had to type echo foo, GPG, no default keyring, temp, GPG, random, encrypt, armor, auto keylocate PKI, -r, test at pba.org. It's so user-friendly. GPG really does not want to be patched to do this. It has a bunch of DNS code in it. It's only present on the encryption side. The amount of rework that's going to be necessary to make this happen, effectively, this work needs to be done inside of Enigmail. It's hideous. But, all right, I started it a little. Then I went ahead and looked at anything else. DKIM. DKIM is a scheme for retrieving public keys, not certificates, for domains outside of DNS. It is pretty trivial to get end-to-end validation out of it in terms of So its goal is this mail server and that mail server want to know, okay, Google wants to know it's getting mail from the Bank of America server. The Bank of America server signs all of its mail with a particular private key. Google looks up the public key in DNS, validates the mail, only delivers it if it validates. That's cool, that's nice. There's no real user experience designed into it. Right now it's mostly an anti-spam system. Super trivial to do DNSSEC with it, and IETF is looking at making that happen, but I'm not really a fan. I want there to be a user experience. And the best user experiences out there, and that ain't saying much, is from SMIME. SMIME is the email encryption and decryption buttons you see inside of Outlook and inside of Thunderbird. There claims to be a plugin for Gmail. It doesn't verify. It's dead to me. SMIME has some key management problems. This is an understatement, but of course it has key management problems. It's based on certificates. Even if you have the greatest enterprise CA in the world, meaning you have wonderful systems for sending email and getting everyone in your organization to have certificates, SMIME has a problem, which is some cheap little shop on the internet has root certs, and they will go ahead and ship a cert for any email address if DNS tells them they're supposed to. And you know nothing could go wrong with DNS. So can we fix this? Actually, can we? We are able to hijack OpenSSL because of LD preload. We are able to hijack the browsers because of secure proxy. How are we supposed to hijack Crypto API? The only extensibility point inside of Windows that we could find lets you reject certificates but not allow them. It doesn't let you say accept a certificate that's self-signed. Now we could write an Outlook plugin, but who wants to do that? There's another trick, but you'd have to get me really smashed. Like one beer is not going to do it. So I guess we're hosed, right? Raise your hand if you recognize what this code does. Anyone? I'm just going to hope that it's, byte temp jump size equals OXE9, OX90, 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 OXE3, mem copy jump, temp jump size. There's some virtual protect in there. All right. So API hooking is not just for World of Warcraft anymore. Yeah. Most people use these tricks to hack World of Warcraft. We're going to hit Crypto API in Outlook because, damn it, I wanted it to work that bad. It is possible to inject code into any process to alter how it works. We've built FreeGP, which is DNSSEC validation for Microsoft Crypto API. Crypto API has a function called cert get certificate chain. If it returns true, the chain is valid. The call receives all sorts of interesting context about the certificate being validated. I'm not that much of a binary hacking guy. So imagine my surprise to find out when you inject a function with full symbols into a closed source application like Outlook, you get full debugging symbols at that particular point. So here's the certificate in the middle of Outlook with all of its debugging information valid. Awesome. So what are we going to do? So we have this signed email here from dan@thebank.org. Not exactly the most compelling image. Look at those 16 pixels throwing the mark of a war to validation. What we're going to do is we're going to add a checker. This is remote DLL.exe. It's not like I could have written this manually, but I thought if I'm going to use the World of Warcraft approach, I might as well use the World of Warcraft toolkit. Also, the website is securityexploded.com, and I'm pretty sure this is going to security explode this guy's head. I was in what slides? No. So we're going to go ahead and we're going to inject our own cert get certificate chain into Outlook. And when we do this, well, first off, we haven't done anything with DNS. Certificate validation is attempted. It's a totally valid certificate, but there are problems with the signature. Check the signature button. So we get this big red line. Look at that user experience. Awesome. Now what we do is we go ahead and we take the fingerprint of the canonical certificate, the thing that is going to be used to sign mail from dan@thebank.org, and it's 46OC1BE3. We are going to shove that into DNS, 46OC1BE3. Now, this next time we validate the certificate, this value is going to be securely extracted from the DNS. It is going to match the certificate used to sign that email, and the email will now come back signed. This is now the only certificate in the world from any certificate authority that can be used to sign mail from the bank. That's actually not something we've been able to do before. Never been possible. Now, you shouldn't be that impressed because it's 16 pixels. Who cares? What user is going to give a crap about that? You ever wonder why they're giving you so little visual information? Let me tell you. Under the normal SMIME model, we have had so little assurance, so little validation that what we're seeing is legitimate. So what we have is, when the certificate validates, we put a few pixels on. And when it's bad, we're like, eh. We can do better. We can strongly identify email senders now. We can strongly identify the brands. What if that certificate that the DNSSEC was validating, what if that certificate was an EV cert? What if you weren't just getting mail from dan@thebank.org? What if you were getting mail from dan@thebank Incorporated and the green bar experience from the browser actually showed up in email? We would be able to tell users legitimately, when you receive an email from the bank, someday soon, you will know it came from the bank. Conclusion. Oh, go ahead. So, DKI is coming. Get on board or don't, but here's what we're delivering for you to see. We have shown you that DNSSEC can be deployed in 2 minutes. We have shown you that we can achieve end-to-end security no matter how messed up the hotel network happens to be. We have shown you federation for probably good federation for the first time in your career. We have shown you how every OpenSSL application can use this technology using a simple LD preload. We have shown how real browsers are going to have real useful experiences with this tech. And we've shown you how certificate authorities and extended validation are going to combine with DNSSEC to finally give us secure email. That is what I've got. Get to work building, get to work breaking.